You're welcome to another experience of the BJ's Physics Classroom. If you're watching this video on Facebook, like the page. Share it as many as possible so that others may also get it. You know, when you share, you spread the news that invite other people to also come and watch it. So please share it. Yeah, just help me to spread the video. Share it. And your comments are also very important because that is what helps shape what we do here. So your comment is also very important. Please keep the comments coming. If, like I have said earlier, if you have any contribution, if you have any suggestion, if you have any question that is boggling your mind that you want us to deal with, you can write it down, take a shot of it and send it to the Facebook group. I'll let it in and then other people will see it. Then I'll come and deal with it. If you haven't subscribed to my YouTube channel, the channel is BJ's Physics Classroom. Please subscribe. Once you do that, turn on the notification button so that when the video drops, you get it on YouTube. And then also like the Facebook page for me. Thank you. Today's section is a continuation of the Newton's third law of motion and linear momentum. This is going to be the third section. And in this third section, we are going to look at the concept of coefficient of restitution. You know, that concept, coefficient of restitution, has, a lot of uncertainties around it. But we'll do our best, our possible best, to make you understand the little portion that you need to know. So stick and stay and watch the video. Thank you. We first begin with coefficient of restitution. We begin with coefficient of restitution. This is a term which is associated with collision and linear momentum. So when we say coefficient of restitution, what do we mean by that? The symbol for coefficient of restitution is E, and it is defined as the ratio of the velocity of approach, the ratio of the velocity of separation, the ratio of the velocity of separation to the velocities of approach. For a system of colliding bodies, M1, M2, moving with velocities U2 and U1, that engage in collision. Before they engage in collision, they probably approach each other and they engage in collision, because if they don't approach each other, or one of them doesn't bump into the other, there can be collision. If two bodies move separately in their own ways like this, they won't collide. So when we say the ratio of the velocities of separation, we are talking about their final velocities. When we find the difference in their final velocities, so this is before. Now, after collision, we get M1 going into V1, and then M2 going into V2. After collision, they will have velocities V1 and V2. Before collision, they have velocities U1 and U2. So the ratio of the difference in velocities after separation to the difference in velocities before separation, that is what gives us the coefficient of restitution. So this is the definition for coefficient of restitution. Remember, velocity is a vector quantity. So anytime we use this formula, if the two bodies move such that they move in the same direction and collide, then their velocities are all positive like this. We always take into consideration the direction. But in a situation whereby the two bodies move, whether before or after, like this, U2. In this case, the two bodies approach each other. So while this one is moving in the positive x direction, this one is moving in the negative x direction because the m2 is moving in the opposite direction. The initial velocity of this will have to be negative. We'll have to take into consideration the direction and the velocity of this. If in a situation whereby they collide, which is hardly possible after collision, they will move like this. Let's take it that that can also happen, v2, then it means that this velocity too will have to be negative. But this one doesn't really happen. So most of the times it happens with the initial velocity. So all that I'm trying to say is that when the two bodies collide such that their moment, they initially move in opposite directions, then one of the velocities must be negative. If they initially move in the same direction, then both velocities will be positive. But the formula is such that we find a change, so these negatives are always here. So that is how we deal with coefficient of restitution. Coefficient of restitution. In a rebound situation, a situation whereby an object hits and bounces off, an object hit the ground and bounces off, then what is going to happen is that, you know, in a rebound situation, an object moves, hit the ground with a certain velocity. Let that be the initial velocity with which it will hit the ground. After it has hit the ground, it will bounce off. So that will be the final velocity v that it will use to bounce off, like this. The body will get to probably this point. So the body will cover a certain height, capital H, with which it will hit the ground. The body will cover a certain height, small h, that we call the rebound height, small h. In this situation, when we make changes to this formula, we are going to get negative E is equal to, because the ground, you don't remember, it is only the body that is moving. The ground is not moving. So because the ground is not moving, the V1 and the U1s will go to 0. So we are going to have V over U. As simple as that. Because it's only one body that is moving. Only the object that is hitting the ground and bouncing off. So the coefficient of restitution formula becomes like this. How do we bring in the height? U is the velocity of impact with which the object hit the ground. And that velocity of impact, U, is given by 2gs. You know, because of time, I wouldn't be able to go through, but you have done linear motion. And I know you know that v squared is equal to u squared plus 2gs. So when the velocity, when the v is 0, you make u the subject, and then you finally get this one. This s now becomes the height h. Let's call this equation 1. For this rebound situation, the velocity v that it will be given to the body to move up, at the maximum height, the final velocity is 0. In this case, we are looking for this u, this v, which is the initial velocity. That will give us square root of 2g small h. Let's call this equation 2. So when we put these two values into this, that is going to give us negative E is equal to V square root of 2gh all over square root of 2gh, capital H. So 2gh, 2gh. The 2gh can cancel out because we can rewrite this formula as negative E is equal to square root of 2g times square root of h all over square root of 2g times square root of h, capital H. So when this one cancels this, finally we get coefficient of restitution, negative E is equal to h over h. But because height is a scalar quantity, when you consider the motion, you consider the height as displacement. While you take into consideration the direction, then you can bring a negative because the E is supposed to have a positive value. But if you consider the h as height, which is a scalar quantity, then you ignore the E, this is negative. So that the coefficient of restitution value will give you positive. Good. Now, coefficient of restitution has it has three interpretations. It has three interpretations. So take note of this formula very well for a rebound situation using the heights, and then for two bodies that collide with each other. Let's look at the various interpretations of coefficient of restitution. When the value of E is equal to 1, it means the collision is elastic or perfectly elastic. But when the value of E is equal to 0, that is, when the coefficient of restitution is 0, the collision is perfectly inelastic. And then when the coefficient of restitution is between 0 and 1, that is less than 0 and greater than 0 and less than 1, with 0 and 1 exclusive, then the collision is inelastic. Collision is inelastic. So this gives us the three types of collisions that we have. Three types of collision. Elastic collision, perfectly inelastic collision, and then inelastic collision. So thank you very much for watching the video. I know that you liked it, and if you did, share it like I've said already. The next episode, which is going to be the last episode, will deal with the three types of collision that we are supposed to know. And that video will come your way, God willing, on Sunday. So make it a point on Sunday and watch. That will be the last episode on the Newton's laws of motion, linear momentum. We know we have other topics to deal with, yes. After that, if I have some questions that have come in and then I need to deal with, I will make a video on those questions too and send it so that you have it. Thank you for watching the video. It's still your man BJ. Bye-bye.